And it's possible to model the output in RET Screen and Watson. They're both free programs that are available at NRCan's site. But Rob Dumont, who I trust implicitly in all this, says 2 4x8 collectors will get to 2,100 kilowatt hours a year. And it's starting to look like that's just what we're going to do. So. And also, I mean, by all means, this is an area, go to the people selling the materials. Harold at Trimline, locally made panels, excellent. They've got terrific specs. He can steer you right in terms of equipment. Alternately, Sedmec in Calgary handles the Enerworks systems, which are a plug-and-play, or close to it, system. We certainly learned the lesson on the Mill Creek House. It's a much simpler system. We've had a lot less trouble, and it seems to be performing quite nicely. So, so when it comes to designing the PV system, I think again I would go to an expert like Gordon and get this stuff is very expensive, and an improper installation, not getting the strings right, that kind of thing can mean that you get less output for your very expensive investment, it's a little bit dangerous as well. It's really worthwhile to take a course if you're thinking about doing it yourself, and otherwise get experienced help and expertise. But in designing the roof to accommodate them, again, think about the fact that these are going to be up there for 30 to 40 years. They seem to be lasting longer than was originally predicted, and try to get a roofing material that will match, so that you're not having to move them to replace the roof. By and large, the area that they cover will extend the life. It'll keep the sun off the roofing, so it should enhance the life anyway. But it's worth thinking about how you're going to get up there, whether it's going to shed snow. We made a little mistake on the Riverdale project. We've got a little bench up there that made it very easy to mount them, but this winter, when we had that big dump of snow, it held a lot of snow for quite a bit too long. The other 2 winters, it didn't seem to do that, but just the type of dump we got meant that the space that we left at the bottom was not quite adequate. So we lost, a few hundred kilowatt hours for sure, possibly more. And angling the system you want to maximize production over the year. PV is very encouraging and exciting. The cost is coming down fairly dramatically. Putting it all together, the chart shows the total energy consumption for each of these houses, and then how we're meeting it. In Riverdale, we've got about a 40-60 split between solar thermal and photovoltaic, and then we shifted to 20-80 sort of on Mill Creek, and then 100% in Belgravia. And we'll probably go 100% in Parkland. We're still not quite sure. That's an easy system. That'll be a huge photovoltaic system. It'll be ground mounted, so we're not worrying about the area. We've got quite a good site, and we'll be able to use lower cost modules. The more efficient the modules, the higher the cost per watt. So, the more roof area you can make, the cheaper the installation. And in this case, as I say, we're ground mounting it, so it won't matter too much. So there are a couple of sweet spots to look out for. One of them is Energuide 86, and I'll talk about that in a little more detail next. And the other one is 10,000 kilowatt hours a year. I mean, we saw this number after the fact, but if you can get your consumption into that kind of range, a few really nice things happen. You can get rid of the gas line, and when you get rid of the gas line, well, first of all, at that rate, the things that you would normally use gas for, the heating and domestic hot water, amount to about 6,000 kilowatt hours a year. Well, the difference between the cost of electricity and the cost of gas on 6,000 kilowatt hours a year amounts to about the difference in the fixed monthly charges. So you can actually burn electricity for the same cost. And at that point, you can put in electric baseboard heating instead of a $10,000 furnace. You can put in a lot less. You can use an electric hot water tank, which will cost $400 or $500 instead of a demand heater that is going to cost $3,000. And with those savings, you can pay for some of the building envelope upgrade. But you're only going to get there on a good site without the passive solar. It's not practical to try and aim this low, I don't think. I think the payback on insulation levels higher than what we've been working on is very, very small. And you're more likely to find it in better on the electricity side, I think. So the other sweet spot is this $10,000 Alberta government rebate for reaching EnerGuide 86. The cost of upgrading the building envelope is in the $15,000 to $16,000 range to get it to EnerGuide 86, and you don't need to be on a great site to get it to EnerGuide 86. It helps, but it's not essential. The Bonnie Doon house there is at EnerGuide 87, and they got their energy audit. They did the online application, and 2 weeks later they got a check back for $10,000. It's a very, very simple system. It uses an existing network of EnerGuide evaluators. It uses an existing standard, and all you got to do is hit 86 and do this very simple application and get it modeled. So in designing the house, aim for a few points high just in case something goes wrong, because I mean, the next step back in this same program is if you get EnerGuide 82, there's $3,000 available, and for our 2000, basically EnerGuide 80, it's $1,500. But really, I mean, that I think is a game changer, because it pays for most of the incremental cost, and the rest of it comes back to you easily in the energy savings. So we've got 4 other houses under construction that are on target to get EnerGuide 86, and another 8 getting ready to start. So we're hoping to really make them suffer. So when you do this, it's really important to measure it. And net zero energy is really easy to measure. Basically, if your utility bill is negative, you made it. But we need to start assembling a database of what's working well, what's working not so well, what's not working at all, so that we don't keep reinventing the wheel, and we can just go straight to this with no fuss in the future. And there's a tendency to be optimistic about this and succumb to wishful thinking. It's really important to measure it and accept the grim realities and learn from it and not assume it's going to be. I mean, builders are natural optimists. It just goes with the I mean, building is an inherently optimistic thing to do. You're assuming there's a future that's going to be good, that's going to be worthwhile, and all that kind of stuff. So, anyway. It's easy to get carried away, so in interest of that, we're in Bob's house. Actually, he's let us put 60 thermocouples in various places in his house, particularly in the slab at different elevations. And so we've got a grad student from mechanical engineering has put a data logger on it, and we're starting to monitor that. So I think that from these first 3 houses, we're going to learn a tremendous amount and hopefully be able to do better in the future.